All right, largest primes. Say you had the question, what is the largest prime that divides both 9 factorial plus 6 factorial and 9 factorial minus 6 factorial? So that 9 factorial really just means 9 times 8 times 7 times 6 all the way to 1. So that's what that exclamation means. We call it factorial. And 6 factorial would mean 6 times 5 times 4 times 3 all the way to 1. So the last number for a factorial is always 1. It's just repeated multiplication. All right, so now that we know what factorials are, we can simplify this question a little better. So 9 factorial plus 6 factorial we could write as 9 times 8 times 7 times 6 factorial. I can actually cut that off there, and that just means that I'm getting lazy and I don't want to put 6 times 5 times 4 times 3 times 2 times 1. But I'm not really being lazy, I'm being purposeful because I want to make sure that I have something that I can factor out here, because I have two terms. This is my first term and this is my second term, and I can factor out as 6 factorial. So 6 factorials factored out. In other words, it will go into both of these terms. This is our first term. This is our second term. And remember, terms are separated by adding or subtraction signs. So 6 factorial times what will give me this first term? Well, 6 factorial times whatever's left over, so the 9 times 8 times 7. So 9 times 8 times 7 is right there. And then I'm going to see how many times will 6 factorial go into my second term, which is 6 factorial. Well, 6 factorial times 1 gives us 6 factorial, so that's just positive 1 there. So this is like distributive property. I'm factoring out what goes into two terms. And I'm going to back step just for a second. Let's say I was doing something easier. What if it was 2x plus 8? What do they both have in common? Both numbers have an even number. All right, so they're both even. That means 2 will go into both the first term and the second term, since they're both even. So I could factor out a 2. 2 times what gives me 2x? 2 times 1x. 2 times what gives me 8? Positive 4. So just like doing this easier example, we did the same thing over here with the factorials. They both had a 6 factorial, so we factored it out right here. And then we put what remained on the inside. Okay, let's do the same thing now for the second number, the 9 factorial minus 6 factorial. It's the same thing. We can rewrite that as 9 times 8 times 7 times 6 factorial minus 6 factorial. And now they both have a 6 factorial in common. My first term has a 6 factorial. My second term has a 6 factorial. So I'm going to factor out that 6 factorial. And then 6 factorial times what gives us the first term? Well, what remains? The 9 times 8 times 7. So 9 times 8 times 7. I put that on the inside. And 6 factorial times what gives us the second term? Well, if you multiply 6 factorial by itself, you get, by 1, you get 6 factorial. So it's 1, and that's a negative there, so it's a minus 1. All right, so the whole point of that is they have a 6 factorial in common. So 6 factorial is the GCF, or the greatest common factor. Now it wants the largest prime. So just think of 6, 5, 4, 3, 2, and 1, what is our largest prime number? Well, 6 is composite, but 5 is prime. So 5 is our largest prime because the only two factors of 5 are 1 in itself. So 5 would be our answer. Are you seeing a shortcut? Yeah, so really what you can do is just look at, they both have a 6 factorial in common, right? And just look for the next highest prime from there. So 6, 5. 5's our next highest one. So if it would have been 8 factorial, the next highest prime, if we wrote out 8 times 7 times 6, and so forth, 8's composite, but 7 is prime. So that answer would have been 7. All right, you try one. All right, go ahead and pause the video. Try this one. And here's the solution. All right, we can write it as 14 times 13 times 12 factorial plus 12 factorial. And they both have the first term has a 12 factorial, the second term has a 12 factorial. So just factor that out. And what remains is 14 times 13. And then in the second term, I can just multiply it by 1 to get 12 factorial. So 12 factorial is my common factor there. And then do the same thing on the second term, the second number. So 14 times 13 times 12 factorial minus 12 factorial. They both have a 12 factorial in common, so I'm going to factor that out. That's really the key thing, is just knowing that they both have a 12 factorial. That's really the key here. It's not what's left inside the parentheses. I'm just showing that for your knowledge. But 12 factorial times what will give us this first term? That would be 14 times 13. And 12 factorial times what gives us the second term? Just 1, and it's a minus 1. So the GCF is 12 factorial. And if I write out 12 factorial, that is 12 times 11 times 10. Hopefully you've already seen a prime number. We're looking for the largest prime. 12 is composite, but 11 is prime. So 11 is our answer. Hopefully you got that right. And I'm going to give you one more that's a little harder. And go ahead and pause the video. Try this one out. Hopefully you found the shortcut. And now for the solution. All right, so they both have a 22 factorial in common. So we're going to factor out the 22 factorial. And then if we write 22 times 21 times 20 times 19 times 18, have you seen a prime number yet? 22 is not prime. It's even. 3 will go into 21. That ends in a 0, so we know 10 will go into it. Whoops, there we go. 19 is going to be our answer. 19 is the largest prime. All right, now you know about primes. Only two factors, one in themselves, and factorials, just repeated multiplication all the way down to 1. Like 6 times 5 times 4 times 3 times 2 times 1.